So hello everybody, I am not really native Dutch, so I hope you don't mind if I do my presentation in English. But you can ask questions in Dutch and I can reply and see how it goes on. Where's my pen? Oh, here we go, my little clicker. Today we're going to talk about RESTful APIs on ASP.NET Core. Hopefully some of you are familiar with the term RESTful and also with the term APIs and also ASP.NET Core. So it's basically, this presentation is going to be about, it's going to consist out of three major sections, and the theory part and the practical part. I'm going to try to show you how you can implement a RESTful service inside ASP.NET without doing much work, because it's already baked in, sort of. Who am I? My name is Fanie Reynders. I am a senior engineer at Deloitte Digital. I also love cloud technologies, so at night I would do like cloud stuff. During my day job, currently we're not doing so much cloud stuff, but it's getting there. I'm also a very proud father of a 10-month-old. I'm also on Twitter at Fanie Reynders if you want to reach out. I like to blog. There's my blog. That's actually Cape Town. I'm originally from South Africa. That's the most southern point of Africa. That picture is taken. Very beautiful country. So I'm from South Africa, and that's my blog. Go check it out if you want to read some interesting stuff. We have a weekly webcast called SDNcast. There's the banner over there as well that we talk about. It's a Dutch webcast, so I'm going to put in my favorite Dutch words in there and stuff. It's me, Marcel, and Martin. We're doing a show on the weekly news, events, and we also do a demo or two and also feature some of the guests, international guests as well, and local guests on the show. Do check it out on sdncast.nl. Also, lastly, I run a local meetup group called the Dutch.NET meetup. Our next meeting is the 13th of April at one of the venues of 4.net. They are the sponsor. And we're going to be talking about, it's actually about the whole Visual Studio launch that's happened a week or two ago. So we're going to be talking about showing this the new stuff on Visual Studio 2017 and also the .NET Core tooling. So I'm going to dive a bit deeper into that and show all the new things, what you can do about the .NET Core tooling. Okay, on with the talk. Enough of the blabbing. An API. What makes you think if you see the word API? I mean, we all knows about APIs and stuff. It's a application programming interface. But what does it mean? Does it mean it's something that your system exposes? Is it for integration? Yes, of course it's for integration. An API is supposed to be a standard protocol that you define so that other clients or other servers can integrate with your system. Right, so if we quickly look at the definition of API, it's a protocol intended to be used as an interface by software components to communicate with each other. Right, so it's intended to be a protocol, a standard, right? And these modern days of applications and services out there, they are thoughts of building in an API first instead of mobile first. You know, think about the API first because you think about integrations there and then. How you design your API, it has an impact later on in the growth of the system and the scalability of the system. So that's why it's important to have that protocol on a very good standard from the get-go. Next section of the talk, REST. Who can tell me what is REST per definition? Not what it stands for, because it obviously stands at the bottom, representational state transfer. But what does it actually mean to be RESTful service? What does it actually mean? Well, it turns out that if let's say you have a extensionless URL in your website or your service, or return JSON from your service, that doesn't mean you're RESTful. It just means you have extensionless URLs that returns JSON, right? So let's take an example, and we apply the example back. If we take, for instance, an API, let's say there's an app we're building with profiles. We're serving profiles, normal CRUD endpoints, and the requirement is basic, simple. We need to have a list of all profiles. We need to grab one profile, and we need to be able to update and delete profiles. Simple enough. Cool. But then, things change, business change. There's new features coming on, like search, and what more? You have to get a profile with friends now. There's a search coming with. Then you tend to add more endpoints to your service, right? So now you have a get profile by ID, or a get profile with friends by the same ID. So duplicate endpoints doing basically the same thing, but it's okay. This is still manageable. Then all of a sudden this happens. The customer phones and say, you know what, we're supporting XML. We now need to support JSON, and we need to support CSV for shell, for instance. They are big. Please update your API. And we end up with this, and this is only one entity. So you can imagine if you have 60 entities in your enterprise, how it will look like. The duplicate code you will end up doing and stuff like that. Not even mentioning unit testing and testing your stuff, right? Versioning, I can go on and on and on. So the idea about REST is also to solve these kind of problems. Because this isn't REST. This isn't even, I don't know, this is just bad design. Please don't do this. If you have to do this, rethink what you're actually trying to do, what you're trying to achieve. That is more like comparing REST versus RPC. So what you just saw, the previous slide, this is more like the remote procedure calls that one can invoke on a server. It's a function that sits somewhere else. So I'm not saying REST is Batman and RPC is Superman, but if we compare REST and RPC, if we can give one word for each of those statements or titles, I would say that REST is you define resources. It's per resource. You expose resources to be interfaced. Where RPC is just mainly a function sitting remotely that you execute. So just keep that into mind. So on the definition of REST, it is a style of architecture that's based on a set of principles that describes how network resources are defined and addressed. So APIs are the protocol and a standard. REST is the style of architecture. So you combine these two to have RESTful APIs. And that means one doesn't simply call an API RESTful. Having, like I mentioned before, having served JSON or having extension as URLs doesn't make it RESTful. So what does it mean to be RESTful? I'm asking a question again. So let's go a step further through the last section of the title, ASP.NET Core. I'm going to go back to the why is it RESTful in a second. Who has ever worked with ASP.NET Core before? Who has heard of it? Okay, so very familiar faces. Web developers, I assume, right? So ASP.NET Core, in short, it's a it's a brand new framework written from the ground up by Microsoft. It's completely open source. It's blazingly fast, and they included one of these features, like it's open source, cross-platform, modular. I can go on and on like that. Most important for me, it can run on .NET Core, which is also new, by the way, and on the full .NET framework. Which means you can, if you would like to play around with ASP.NET Core or actually implement it in production, which is production ready, and you're scared of implementing it on, you have to implement it on .NET Core, you can also run it on the framework we all know and love, like the 4.6 or the 4.5 or whatever. It will run there. Not as fast, but it will run. It will be supported. And also for me, my favorite feature here is you can use any text editor you want. So in my demos, I'm not going to even open Visual Studio. I'm going to open Visual Studio Code, which is like sort of Visual Studio, but it's a text editor. You can use Notepad if you want to. For me, it just works well for the demo. The features of ASP.NET Core would be, these are the features that I'm going to be addressing, and I'm going to try to align these features with REST and see how can these features help us to become RESTful in our services. There are hosting features, middleware, dependency injection, configuration, logging, and application frameworks like MVC. So by the way, I don't know if you heard, MVC, our previous MVC version, we have MVC, Web API, Web Pages, remember? Now it's just called MVC. Why? Because everything is glued together now as one framework. Why would you have a separate controller for serving data and a separate controller for serving views? In the past, it was literally two duplicate codes, a copy of each other, sitting on separate namespaces, separate libraries. But now if they've unified the pipeline, make it easier for us just to do this stuff. I'll dive into application frameworks also later. So this is the broad picture on how I see the whole ASP.NET Core and where it sits on the whole landscape. This is an important part that I mentioned, ASP.NET Core. It can run on a full framework that's only supported by Windows, or it can run on .NET Core, which is obviously cross-platform. And on top of that, one would have the web forms, web pages, MVC, and web API. And now for application frameworks in the new .NET Core world, we have MVC or your framework next, also sitting there. Thou shalt be restful. Where's this picture from? It's from Ring, Lord of the Rings. So to be restful, it turns out that Roy Fielding, he did his thesis on HTTP, and he defined 6 constraints to be able to qualify to be restful. So there are rules, commandments to be able to be restful in your world. So I'm going to go through these. I'm going to go through these commandments or these constraints, if you will, the RESTful constraints, and then I'm going to go, not each one, I'm going to go through all of them, and then I'm going to go on 6 demos, showing you each constraint in a physical implementation in ASP.NET Core. So you have the theory and implementation, you can make up your mind. So the first one is client-server. We all do that long ago. We've done that in the past. It's websites, There needs to be a client, there needs to be a server, and the abstraction needs to be there between the server and the client. And the abstraction meaning there needs to be a physical, not a physical really, but a abstraction between sending a message across to the server and getting a response back to the client. An example how you would implement this in ASP.NET Core is basically 2 lines of code. It looks like 6, but it's 2 lines of code. You would instantiate a web host builder, which is the host that's hosting your application. Then you would use Cashflow, which is a cross-platform, blazingly fast HTTP server from Microsoft, also open source, by the way. And then you configure the application to say, when I hit my endpoint, which is the default host, I would like to return hello world to the response context. And you build it and you run it. There's your server. Then you can use a client like curl or Postman to invoke the host, and it will give back hello world back. So that's the first constraint in code. Next one is layered system. So it's a bit of a confusing one, because what does a layered system mean? Well, layered system is that a request goes through certain layers and it can be intercepted by certain layers, or it can be covered by certain layers. Intercepted meaning a request doesn't have to go all the way through the pipeline. It can stop at a certain point and return. Think about authorization, or think about logging. That's an example. Logging lets the request through. Authorization will stop the request in its tracks and send back a proper response. But also layered system also means more than middleware. It means it can be other APIs, talking together. So that's a bit of a confusing, but the idea is if there is a notion of layered system in place, it means your service is RESTful. So this is the ASP.NET Core middleware, how it works. So a request comes in to the host, it passes through the server, in this case it's Cashflow. Then it goes through middleware 1, 2, and 3, and your application. I haven't included application here. So let's say the middleware 1 is authorization middleware, and you come in, you send a request that it's not authorized. The middleware 1 will immediately return back to a certain response. But let's say middleware 1 is a logging middleware. It will let it through to the other middleware and just do its stuff here. And it's completely loosely coupled from the rest of the middleware. You can author your middleware in any order you want it to be executed. Do you guys remember HTTP modules back in the day? What was it? Pre-init, post-init. Middleware is easy. It has invoke. That's it. Most of the stuff in ASP.NET Core, it's done by convention. The signature of a middleware, I'll get to that in a sec. ASP.NET Core looks at a certain signature, and if you have that signature, it will invoke that as a middleware. Excuse me. Right, so one of the most important things on or constraints in the RESTful world is called the uniform interface. Think of it as a almost like when I say as these three things. To be able to be uniform, you need to be uniform in a per resource, per method, or per media type. So meaning you need to be accessing the service for a particular resource for a particular reason, get, put, post, delete, to be able to get back a particular response. Right? So that's your media type. I want a picture, get a picture back. I want JSON back. So that's the uniform interface. So you address a resource, you want to be able to take an action on a resource, and you want to be able, that response needs to be in a certain format coming back. So let's take our example, our awesome API that we tried to attempt earlier, our RESTful API. Let's create a RESTful API from this. So I would say do this. Let's group our endpoints into HTTP verbs, first of all. Because having endpoints get profile, post profile, it's really redundant. We nicely group our profiles, all our get stuff, so we get all the profiles. We get all the profiles for a specific name in a query string. We get a specific profile, or we get a specific profile's friends. And this, all these endpoints, or one of them, it doesn't really matter, can accept JSON, or it can accept CSV. Okay, so that's the get part. The post, and the put, and the delete, fairly self-explanatory, but you address the same endpoint as you would have done with the get, to get all, but instead you have a post to this endpoint, given then a body, what you want to be creating. And then that response, that payload coming back, would be, hey, this was recreated at this endpoint. Bit of out of scope for now, but that's what will happen. The put is the same thing. You get put and patch in the HTTP world. So I want to be able to update a specific profile, not getting it, update a specific one, so these one and these one match together. But instead you say put to the same endpoint, giving an object, and it will update that whole object with the values you provided. Now what it's patch is more like a delta update. So you want to only update a name. You only give it a name, the server will figure out what to update where, because you're only giving it a delta value. Delete is also the same thing, same URL, or same endpoint rather, but you specify delete and it will action the delete endpoint. Now we have stateless. Now, for me, this is also very important because a service, any service actually needs to be stateless. Look at web forms. Web forms are not stateless because they are view state going all the way around. You create sessions on the server, right? Sessions expire. Nothing wrong with creating sessions, but your service needs to be stateless. So what does the stateless means? So if a client sends a message to a server, the server doesn't need to have prior knowledge of the scope or what needs to happen. All the information that's required for this whole thing to work needs to be in this message for the server to understand the request. So it needs to be able to sort of, if you need to use like a session, send a session key. If it's distributed cache, like a Redis cache or something, then the client would send a request to the service with its key saying, this is my cache key, the distributed cache key. It will go off to an external service, grab that cache and load it in, for instance. But it doesn't need to have a local copy of server cache to be able to work because it's driven by statelessness. Statelessness also means that stuff is idempotent. I think it's the right explanation, which means you can send many requests to the same endpoint. It will act exactly the same. It won't have any other effects or other behaviors because each request is unique. Which brings me to the subpoint of statelessness. Who has heard of Helios before? So, one person. What does Helios stands for? So it's hypermedia as the engine of application state. Have you implemented Helios successfully yet? Okay. Have you tried? Okay. Wouldn't bother. So what Helios means, it means that the server drives the application state. So how can I put this? We have application, right? So if we need to sort of, let's say we have an app and we have our service. We give our application hard-coded URLs, say people/friends. Then you send the friends, it gets payload back. Okay, now I need to post to this /people. So the client constantly is glued to the actual implementation of the URLs, right? So what Helios solve is the client doesn't know anything. It just says, give me some options. So the first thing it does, it executes the routes of the service. The service brings back metadata, at that point on the route, what it can do, given a certain authorization scope. Then it will, send you back. Okay, you can update the user, you can delete the user, and this is its endpoints. I'll actually show you an example. But first, the definition of Helios is it's a constraint of the stateless application. So it sort of extends the stateless application constraint that allows a REST client to have no prior knowledge about how to interact with the server beyond a generic understanding of hypermedia provided by the API. So this is the other way around. The previous one, the server doesn't need to have prior knowledge of the client. This one is more driven from the server. So the client doesn't need to have prior knowledge of the server. So it's driven by hypermedia provided by the API. So metadata is given to the client on the need-to-know basis only. And so the client morphs into the state that it needs to be. Here's an example of a Helios response. I just took a sort of a bare bones example. There are plenty of implementations out there, like JSON Hull, for instance. It's specifications you can go read up on, how that's standardized implementation. But basically what it is let's say I've got a Joe Soap response and white. Instead of having just Joe Soap, you'll have an extra additional, depending on that certain state of the application, the service will send back a links payload with a property. Each one containing a relation and a href, a URL, what it can do, and an optional method. The first one will obviously be, who am I? Where did you get this information? So you got this information from myself is this. And if you don't specify method, it's get automatically. But you can also do update person. This is the URL of update person, and put is the action. Same with remove person, URL and delete method. So you can imagine that the client only needs to know about these keys really, and it gets these keys as it moves on. You know, from the route, it gets certain keys. Then from each key, it grabs the URL, it binds that URL with its method, go through its service, invokes the service, just whatever response comes back. So all the client needs to do is understand how HADIOs work with the links mechanism. The rest will just work. I think this is the 5th constraint. There's actually 5 required constraints. It's the cacheable constraint. So having state and having a stateless environment also requires, because of performance, one would have a cacheable implementation. So it needs to be cacheable. I don't say you have to implement cache, but it needs to be cacheable. Allow cache to be happening on your service. I've seen this in the past where a service responds with a list of profiles, but the actual method they call is a post. That's not posting anything. That's getting something, which means you cannot cache that because it's post. You know, by design, HTTP doesn't work like that. So be cacheable. You can use numerous techniques to cache your payload: client-side caching, server-side caching, distributed caching. One interesting technique is browser caching. It's by means of e-tags. So let's say you do a request to a languages endpoint, to this awesome API. The response you will get back, the header would be, for instance, we would cache this for, what's this? 36, no, it can't be 36 seconds. I cannot think now. No, it can't be 1 hour, can it? Well, whatever. We'll cache it for so much. I don't know if it's 3 seconds. No, it can be. Maybe it's just 1 hour. But important is you have this e-tag. This is a sort of a server-side cache snapshot, not of the data, but of the request. All right, that the server gives you. The browser is implemented, or the client is implemented to understand e-tags. So when it does the exact same request again, sending a if non-match header with that e-tag, you won't get a response back. Well, you get a response back, but you won't get any body get back. You will only get back 304 not modified. Depending if it was modified, you will get back a response. But 304 not modified, a lean header with the same e-tag. So it will constantly go on like that until something has changed, or the cache has busted or expired. Then you all of a sudden will get the cache back. So you can immediately see there's a very, very good performance on network traffic. Not network traffic, but network traffic. The last constraint is optional. You don't have to implement it, but we sort of already do. The code on demand constraint. You can tell me what that is. Just take a guess. No one? Really? So code on demand is basically, it works. Well, we've done it before. Now, can you tell me what it is? So if we load jQuery from our site, we're doing code on demand. We're getting logic from a server. It's a static file, but it's logic from a server that gets executed, and it can potentially modify the client. So this is code on demand. And it's actually possible not just for web applications. You can do this with WinForms applications, WPF applications. How would you do that? Well, if you have dependency injection set up properly, and the request goes to the server can actually send back a binary file, which is this class, that might implement a component in your client. When that response gets back, you know that response is a DLL. You immediately load that DLL into the dependency chain, execute that interface's action, and then you would have extra logic from the server. As easy as that. So that's an example how one would actually do it in that scenario. Okay, now I'm quickly going to do a quick demo on all those 5 constraints. You guys are still with me here with these constraints. You can still remember them. I don't hear anything. I just like assume stuff. Just all sleeping. Wake up! It's demo time. Hopefully, it's just a cool. We all can see there. It's a bit. Right. So the first one, the client-server constraint. Who has ever seen the new ASP.NET CS Proj, or who has ever seen the new tooling of .NET before? So they recently had project.json, and they've moved back, or like initially had project.json, now they moved to project.json, and now they moved back to CS Proj. Does that make sense? Why? Because it's backwards compatible. The guys doing Mono and Xamarin and that kind of things. The investment was too big to change everything to project.json, and also your XML has benefits over JSON in some scenarios. But they didn't just go back to the old CS Proj. They actually went back and took the best parts of project.json and the best parts of CS Proj XML, bind them together to give you the new project.json. So this is my CS Proj of my project. You can actually read it now for a change. You know, very simple. I target .NET Core App 1.1, which is the base SDK, and I also include the ASP.NET Core package. Klar, done. That's basically all you need. My program, like I mentioned earlier, it's a bit more of a modified version of my web host builder, but I have a web host builder with Cashflow. Then I configure it to run whenever I get a request. But in this case, I just log the request on the screen so that we can see what's going on. And at the response, I just say hello from whatever path you passed in, so that we can see if we can get the same result back. And to show I'm not really cheating about the whole client-server thing, you can actually run Bash on Windows. You guys know that? Like Linux running on Windows. That's actually, for me at least. Here I've got Bash, which is the Linux subsystem, and here I've got command prompt, DOS, whatever. So I'm going to run my service on this side. I'm actually going to stand and type for a change. This is how you run a .NET Core application from the command line. Just say .NET run. Wake up. Okay, now my server is running, and it's pointing at localhost, where it's listening at localhost 5000, port 5000. And if it is, here's my history. If it's good, then I can actually use curl to query it. Now, I'm going to execute on the right-hand side, which is the client. The moment I execute, check on the left-hand side what's happening. So, see, it got a request from that to the route, or to the root of the service, and it got a response back. Request response. Ooh, not that major, right? So, basic client-server constraints. That's how I implement it. Very easy. Okay. I've learned to shut down my server because all my demos has the same port. So now let's build a server. Yay! Friday afternoon. What time is it? I don't know. Do I still have time left? So it turns out that in the new ASP.NET world, you can create your own server. If you don't want to use Cashflow, I'm not saying not using IIS. If you're going to be hosting on Windows, use IIS. Underlying, use Cashflow for speed. IIS can heat traffic. Cashflow is made for speed. So think about it as the whole scenario. We have Apache or Nginx that's routed to Node or something. Think about it that way, because Cashflow is made for speed. IIS is for durability. And if you want to create your own server, like in my case, you know, previously we had use Cashflow. That's just syntactic sugar for use server as new Cashflow server. But now, in my case, I created a awesome server and I pass it a path. So the idea of my server is I don't want to listen from a network location, from network ports. My server wants to be able to listen from a folder path, to get a request from a folder path, a request that you define in a file. You put the file, it's almost like BizTalk days. You get with a path, take that file, put it in a folder, then the server will pick that file up. It will run it through your ASP.NET pipeline to your application. Whatever response you'll get, in my situation, it writes back to that same file on disk. Interesting? So it's a scenario. That's not really, it's useless, but it's sort of a scenario. I like to think of these useless things to sort of make my life more interesting. So now, instead of listening for a URL, I'm listening for a folder path. And just to point out, I'm not going to go into details. This code will be on GitHub after the session. But you basically implement iServer. And there we go. There we have a server. It's not that easy, but just go check out the code. It's actually interesting. How it works then later is I also then have this use startup path, because the earlier, my previous demo, I had a inline declaration of my application. You can totally do that. But they've made it easy to sort of do a class. You say, whatever startup things I want to execute, use this class. This is now called startup, for instance. And it looks like basically like this. It has the same functions, the signatures it needs to invoke, but just on a different class. It's just more readable and stuff. And then to be able to create the server, I would have need a HTTP context, which doesn't exist on a folder, but I created one because I've implemented HTTP. I've implemented HTTP or inherited from HTTP context. I also need a HTTP request because a server has this notion of features you have to implement, like a URL feature, also a request feature and response features, many other features like the HTTP spec or whatever can dictate. But to be able to be a server, you need to minimally implement the request and response feature, which I've done. So I've made mine file HTTP request and done some hacky code to make it work, because remember, we don't have a network thing we're listening on, and also HTTP response. All right, so basic idea. We have this. So we have our awesome server folder, the process folder that we listen on, and then we have our two requests. So the one request basically looks like this: get space and the request name, test1. And the other one is just get space test2. That's all that's in the file. The moment I'm going to use both of them, the moment I'm going to be copying them, copy. The moment I'm going to be pasting this into this folder, see what happens on the left-hand side. I'm logging everything. Nothing, because my server hasn't started. Let's see how to delete this. .NET run. Okay, now also it's important to point out, now listening on that path. It's not a network location, it's a folder. I haven't changed much, I've just implemented my new server. That's all my code, the rest of the code is still exactly the same. So now let's paste this again. Request starting at route, invoking the test2 endpoint, invoking test1 endpoint. So it logged it, and it kept my files on disk, but now remember, I've said my response get written to the disk as well. So let's open test1 again. I'll get my HTTP status code, which is not implemented yet, so I just put 0 in, and here, hello from test1. To show you I'm not kidding around, if we go to our little startup file, I've defined two endpoints. When I go to /1, test1, I invoke it, and /test2, invoke it. So this can be any application. I've just implemented my server on top of that, and it worked. Excuse me. Right. You guys ready for the third constraint? You can remember what a third constraint is. Layered system. Remember the whole layers? So in ASP.NET, you define your layers as, I would say, middleware. And middleware has a certain signature. As long as it has a function called invoke that receives a HTTP context, it makes it a request delegate. It can actually be a middleware. Then from your application builder, you say use middleware, type of middleware 1, middleware 2, middleware 3. And guess what they do? Well, the same as that slide I've showed you. They basically say hello from middleware 1, hello from middleware 2, hello from middleware 3. They each log something at the response. And like I mentioned, it's dependent on the order you set them on. So this is on ASP.NET level. There's no MVC involved. It's on ASP.NET level. MVC has its own middleware layer as well, where you can slot in middleware, but that's MVC specific. I'm talking more about the bare bones middleware component. At the end, it's going to reach my actual application code, which is awesome, right? And it's going to be executing awesome, and it will work. So same thing we're going to be doing. Okay, great. Same thing. We're going to be saying .NET run. Did I stop my other service now? I can't remember. No. Okay, so now it's listening on port 5000. Now let's curl this guy. So curl to 5000, execute it. Is it executing? What's happening? Something's happening. I don't know why. What's happening now?
You need to click in the left.
No? Okay, great. Doesn't want to work. Why is that? Again, there's something wrong. Yeah, it ran. Let's just try this again. Okay. .NET run. Okay, now it's working there. Just quickly do a ping. Will this work in Bash? Okay, unknown host. Doesn't find a host. Yay, okay, so now it worked. Requested it and it went through my middleware. Hello from middleware 1, 2, 3, and eventually it goes awesome. Response. Awesome wasn't locked though, so it's my response. Awesome. It just looks weird on curl because if you don't give certain parameters through, it sort of messes with your format. Okay, now let's go a step deeper into MVC. MVC is the best way to show you how you can actually do the whole uniform interface constraint, the whole get, put, post, delete thing, and it's also already happening in the past. So I have an API that serves profiles, like we've mentioned. I'm not going to connect to a database. I'm going to be, like I mentioned, I want to be trying to use features from ASP.NET to make up my demos to show you all the features of ASP.NET. So I'm going to be reading from a JSON file, but I'm going to be reading it from a JSON file into a configuration model, strongly typed, and then my application will use my strongly typed configuration as my results for my API. So it's from JSON. I'm going to read my response from. But I don't have any, and this is also just a small little side project I've been working on. I don't have any responses right now. So how does one generate responses in this scenario? I want to create a mock response. How do you guys create mock responses? Do you use a tool for that, or what do you guys use? don't you create mock responses then? Okay, so in my case, I've created a little tool called Expando. So what Expando does is it allows you to do stuff like profiles, give it a label, and you can go, I want to be able to have an ID, and it's int. I want to be able to have a name, and that's called a first name, F name, and also surname, and that's a also it can be string or whatever, but I'm going to that's a last name. That's a type actually, and I'm just going to copy this. So, and then also I want to be able to have friends. And my friends is the same thing, right? So the same object, but I want each one to have about 3 threads, and I want a whole collection of 10 profiles, for instance. So this is my syntax I've now inline created. So now if I hit Shift Enter, it created my my JSON for me. Cool, eh? It also supports XML. Same syntax, XML. Oh, that's not. Oh, that's a JSON. The same syntax equals XML, right? XML. The same syntax. It supports SQL and that stuff, but it's quite cool. Let me show you SQL. Done. Cool, eh? So here's my JSON. I'm going to save it into my program. So then what's going to happen in my configure services, the first thing I want to do is I'm using dependency injection. This is how dependency injection in ASP.NET Core works. You'll say you configure your services in this configure services method. Then you say add singleton, and you map your interface to your implementation as a singleton. It's obviously because you can read it as a singleton. Then I want to be able to configure my services to be able to use a strongly type of the list type of profile, and it needs to map it from my configuration property, which is defined on top. That's my configuration. That's my configuration object. I need to get a from that configuration, from my system configuration, out of the profile section, whatever is in there, I want to be mapping it to a strongly typed object. So this is how I load my configuration into my strongly typed class. Then here I'm adding MVC core. It's important to point out that you can have .mvc, and it's not adding the old MVC, it's adding the ASP.NET Core MVC. But this add MVC core is the core bits of the ASP.NET Core MVC. So it's not whole MVC. You don't get Razor, you don't get views and all that stuff. This is the bare bones, right? So I've included the bare bones to be able to show MVC, but not the whole thing. You know, performance and stuff like that. You have to sort of take note. I've also mentioned that I want to be able to serve CSV. So this is how you do it with output formatters. So I've created a new output formatter. I've added a new CSV output formatter to my MVC pipeline. I've added JSON because MVC core doesn't come with the JSON formatter. So I add now my JSON formatter because the response needs to be formatted into JSON. And I also want to be able to add JSON options specifying my response. I need to negate nulls, and I want to be able to format them. And hit configure, the same as we had in the program, but now it's in the startup class. I say use MVC. So we'll take this whole configuration, and it's going to be using MVC, and it's going to start up. Just a quick on the output formatter. To be able to be an output formatter, you need to inherit from an CSV. You need to inherit from an output formatter class and implement it, and then MVC will pick it up as an output formatter and stuff like that. Not to bore you with any details, so let's see if we can get some names here. Okay, so I have my server. Now I need to start. Did I stop my previous one now. Okay, .NET start, run. Okay, so this is working. Now I'm going to be using Postman. Back up your Postman data. No. Postman to get my responses. Can you guys read there? Is it still fine? That's still fine, right? Great. So invoking our first endpoint profiles. This is actually getting it from our configuration file, from our JSON file already. There we get all our profiles information as expected. Yeah. But we also have a specific, well, that one that doesn't exist, so I have to pick one that exists. So let's just see here. Take 437. There's the get one. You get the idea. Put post, it will all just work. So how does it look in ASP.NET World? Well, you have a controller, and I've implemented I inject my profiles as I options, type of list of profiles, into my constructor. MVC knows, or ASP.NET knows about my list of profiles. It is options, and then I load it into my private variable. Then I have a get all, right? That has an optional name, which is a get request. I've get one, and what does this mean is that's your URL template. So it will take whatever is on top. I must stop moving around. It will go the route / whatever the controller name is. In this case, it's profiles. Why do you want to do this? Because, well, if you're going to be hard coding it and you're going to be changing your profile controller, you might have a discrepancy. So I'd like to do it like this: controller, and it will it will take profiles and append ID to it. Same for friends. So you have for friends whatever ID / friends, post and put, and it all works well. It's important to point out, if I, for instance, do a post, I need to specify a body to this endpoint, and I want to post to profiles. Look at my response I'm getting back. It's a 201 created, right? And if we look at the actual headers that we got back, it has a header location where the actual guy that was created by the server. Where is the other thing now? Oh yeah, so 201 created on the far right, and then it gives back the location, so the client can know to get that profile, it needs to go and access that endpoint. So it's also a bit of HTOs sort of built into HTTP. What more is here to show? I don't think there's anything more here. Okay. Last but not least was HTOs. Like I've mentioned before, it's a normal resource. You know, we're returning profiles and persons and all that kind of things, but it's actually resources. So now what I've done to be able to make it HTOsable, if that's a word, I've created a abstract class called person, a resource. In here I've got a collection of links. I just call it _links. The order for -2 is just to make sure it's on the very top. Each link basically has a rel, href, and a method. In other words, a relation, a link, URL, and a method. And then I make my person a resource, because it is a resource, right? And how do you use it? Well, in our scenario, we have people get 2. So in that scenario on the example on the slide, I return Joe Soap, which is fine, on my get with a certain ID. This ID maps to this, and you can name your route to get if you want to, optionally, but it infers it from this. You don't have to specify get there, but if you want to have fancy URLs with the query parameters, you need to define this. But let's say you don't have this in there, you can leave this out. By convention, ASP.NET recognizes the get as a get method. Any case, create a new person, I add my link to my person self, then I add a URL link to the get function, I pass in my parameters, update, I want to create a link to the put route, specifying the parameters, and I link it to delete. So I'm not hard coding my routes, I'm letting ASP.NET do it for me using the URL helper that you get free. And because it's now inherited from a controller base, you can do anything you want. The reason why I've added MVC core is you also don't need to have controller base. If you're not going to be using the URL, you can actually leave this all out. Look at this other example. See, there's no controller. So MVC infers this is a controller because it ends on controller. It's a POCO class. In fact, there is now MVC bits in here because I use I options. But if you don't use I options, you don't need to reference MVC in your POCOs. You can have it a normal class. There's also code on many websites to show you how to change this convention to SDN event if you want to. So it will replace all the SDN events as controllers, or recognize them as controllers. The last one, is this the last one? Yeah. I'm not gonna, must I run this? Yeah, let's quickly run this, I've got some time left. Sorry, I just want to get my proper desktop. Okay. Localhost / person / people 2. You guys can probably see there. Get a response back. Links. Joe Soap. Ooh. Not that hard, is it? Last one is the Cashflow constraint. Not going to bore you with the details. What I do going to say is, however, I'm going to show you a quick demo on what I mean, and then I'm going to show you how I implemented it very, very quickly. Just quickly going back to my previous desktop to stop my service, and then we're going to show you how this puppy works. So I've got .NET Run. It's almost beer o'clock, don't worry. See the sad faces there. Alright, so for this example I'm using Chrome. Wow, why is it so zoomed in? Okay, so I'm using Chrome now. I'm going to go to HTTP localhost 5000, what was that? Languages was my endpoint that I've implemented. I'm going to hit my response, and I get my response back here in Chrome, right? So it's a client, it gets a response back. Language codes, Danish, Norwegian, English. My languages response here is 200. I got a size of 467 bytes that I got back. We inspect the whole, how do I? It's a bit difficult, eh? How do we get rid of this extra bar? Is it possible? Let's deattach it. Okay. So my normal response is normal OK, which is fine. My response is that, right? So now let's go and do this again. Exact same call. Do it again. Network. Actually close this guy. So look, F5. Now I get a 304, not modified. Interesting, but I still get my response. So the server, the client knows, you know, I've got a 304 not modified. He knows to take its client-side cache off earlier and apply that as the response. What I actually got back from the server. This is not what I actually got back from the server. What I actually got back from the server was only not modified, and I got an e-tag, and my request. Hello. I send my request in if not match. Right. So implementing this is very easy, and it's seriously it's stupid easy. How many times I do this, I get 304 until the cache expires. So I can, and also look at my size. It's 326 bytes. You can immediately see the response was less. How does it look? Well, inside our CS proj, we add a NuGet package. You know, if you can't do it, if you if you want to be lazy like I am, I use like packages and pre-written code. I use the Marvin cache headers NuGet package available on NuGet. Add that guy, and it will do the whole headers for you, with checking for cache keys and e-tags and stuff like that for you automatically. Once it's added, you just have to tell ASP.NET about it. On your services, you say dot, and it will appear as add HTTP cache headers. You can give it options, give it a max age, and you have some validation options. When should it invalidate? Must revalidate or add proxy revalidate true, etc. The rest you know with the previous demos. And in the bottom, I have used HTTP cache headers. That is it. It's important because I've defined this whole thing before MVC Core, and I'm using it before MVC Core as middleware. Otherwise, MVC will invoke the thing without the cache it being cached. So it's how it works. Okay, what do I have here now? Am I still on the screen? Not? Let's see. Yes, I'm on the screen. Good. Okay. Not? No. What's happening? PowerPoint. Windows. Go away. What's happening? I'm not doing anything.
Next slide.
Okay, let's go. Let's do it again. Yay! Now it's working. Okay, still wake up. It's beer time almost. So the takeaway of this message is today is basically I really ask you guys, don't just call your service a RESTful. Go and implement it RESTful with the constraints defined. Right? Think about what you want to do. If the thing gets too complicated, go back to the drawing board. Think about scalability. Think about maintainability. Don't just call your APIs RESTful. Get rid of these quotes and make it truly RESTful, using the 5, maybe 6 constraints that's provided by you. If you guys want to know more about Visual Studio and .NET, etc., go grab them at visualstudio.com. My code editor was grabbed from code.visualstudio.com, which is Visual Studio Code. Also, if you want ASP.NET, you can go to get.asp.net, and there's extensive documentation now on the new docs site of Microsoft, docs.microsoft.com/asp.net/core. Very easy. So I want to thank you guys for coming to my presentation. If there are any questions, I would like to answer them for you. Thanks.